The Boötes Void. The Boötes Void is one of the most profoundly empty and eerie structures ever found in the universe. Discovered in 1981 by a team of astronomers led by Robert Kirshner during a redshift survey of galaxies. Located roughly 700 million light-years from Earth in the direction of the Boötes constellation, it stunned researchers with its sheer absence of galaxies. The void stretches approximately 330 million light-years in diameter. To contextualize this scale, the Milky Way galaxy is about 100,000 light-years in diameter. That means you could place more than 2,000 Milky Ways side by side across the Boötes Void. Its volume is estimated at over 236 billion cubic light-years. If the United States were projected into this space, it would fit more than 2 billion times over, making it one of the largest known structures of emptiness in the observable universe. What makes the Boötes Void so profoundly unsettling is not just its size, but the level of emptiness it contains. In a region of that volume, scientists would typically expect to find around 2,000 galaxies based on standard cosmic density. Instead, fewer than 60 galaxies have been detected. That's less than 3% of what should be there. It's not just underpopulated, it's a cosmic desert on an incomprehensible scale. One of the prevailing theories suggests that the void was created by the gravitational merging of several smaller voids early in the formation of the universe. This would have left behind a massive bubble of near-total nothingness. However, this theory doesn't fully explain the scale of the void, nor why it's so geometrically smooth. The Boötes Void is terrifying, not because it's dangerous, but because it challenges everything we think we know about the structure of the cosmos. It suggests that the universe might contain regions completely cut off from galactic activity places, where, if you were placed inside, there would be no visible light in any direction, no stars, no galaxies, no cosmic radiation strong enough to illuminate the dark. From a human perspective, it's one of the most extreme expressions of cosmic isolation ever discovered, a reminder that the universe is not uniformly vibrant, but stitched together with patches of pure, silent, endless void. The Eridanus supervoid. The Eridanus supervoid is one of the most bizarre and colossal voids ever identified. First identified in 2004 by astronomers studying data from the Wilkinson Microwave Anisotropy Probe, which maps the cosmic microwave background, the faint afterglow of the Big Bang. In the direction of the Eridanus constellation, they noticed a large cold spot, significantly cooler than surrounding regions of the sky. Further investigation revealed that this wasn't just a temperature anomaly, it coincided with a massive underdense region in space. Located approximately 1.3 billion light-years away, the Eridanus supervoid is believed to span nearly 1 billion light-years across, making it one of the largest voids ever discovered. For scale, a beam of light would take 1 billion years to travel from one end to the other, which is more than 7 times the current age of multicellular life on Earth. And if a single banana were 20 centimeters long, it would take 5 quintillion bananas to stretch across the Eridanus supervoid. Unlike typical voids, which are already sparse, this supervoid stands out for its extreme size and the depth of its emptiness. It contains significantly fewer galaxies than expected for a region of that magnitude. What makes it so disturbing is the potential connection between this void and the cold spot in the CMB. Some scientists theorize that light traveling through the underdense region loses energy, creating the cold spot via the integrated Sachs-Wolf effect. However, this explanation is not universally accepted. The phenomenon remains scientifically controversial, leaving room for alternative interpretations, including ones that extend beyond the boundaries of known physics. Some speculative theories suggest the Eridanus supervoid could be evidence of a collision with another universe, or the result of unknown large-scale forces at work. Even in more conservative models, its vast emptiness forces cosmologists to confront the possibility that our understanding of how matter distributed itself after the Big Bang might be incomplete. The Eridanus supervoid is terrifying, not because of what we know about it, but because of what we don't. It's a billion light-year wide question mark stitched into the fabric of the universe, defying conventional structure and hinting at forces that may exist far outside our current comprehension. The Great Attractor. The Great Attractor is a gravitational anomaly so powerful that it's redirecting the paths of entire galactic superclusters, including our own. First detected in the late 70s and early 80s, not by direct observation, but through its gravitational influence on galaxies. Astronomers noticed that the Milky Way and hundreds of thousands of other galaxies were all moving toward a specific region of space at a speed of approximately 600 kilometers per second, fast enough to travel from Earth to the Moon in 11 minutes. This mysterious pull couldn't be explained by any known mass within the visible universe at the time. The problem was that the source of this immense gravitational force lies behind the zone of avoidance, a region obscured by the dense gas, dust, and stars of our own Milky Way galaxy. This made it incredibly difficult to observe directly using optical telescopes. The region itself is located about 150 to 250 million light-years away. To put this in scale, the light currently reaching us from the Great Attractor started its journey around the time early dinosaurs appeared on Earth, near the constellation Norma, at the center of the Laniakea supercluster, which includes our Milky Way. What makes the Great Attractor so terrifying is that we are influenced by a force we cannot see. It's a gravitational anomaly, possibly a supermassive concentration of galaxies and dark matter, dragging entire galaxy clusters, including ours, toward it. Later studies identified the Norma cluster as a key contributor, but the full structure and scope of the Great Attractor remain hidden. Adding to the unsettling mystery, some scientists believe that the Great Attractor is itself being pulled toward an even larger and more massive structure, the Shapley supercluster, which lies farther away in the same general direction. This recursive pattern structures pulling on structures reveals a cosmic tug-of-war that we don't fully understand. The horror of the Great Attractor lies in its invisibility and scale. It's not a place we can travel to or observe directly with ease, yet it exerts force across hundreds of millions of light-years, dragging entire galactic systems like leaves in a current. From a human perspective, it represents the existential terror of being caught in the flow of a universe guided by unseen forces that may never be completely revealed. Gamma-ray bursts. Gamma-ray bursts are among the most violent and destructive events ever observed in the universe. First detected in the late 1960s by military satellites monitoring nuclear tests, these sudden, high-energy flashes of gamma radiation have since become a central focus of astrophysical research. They occur unpredictably, last anywhere from milliseconds to several minutes, and release more energy in a few seconds than our Sun will emit in its entire 10 billion-year lifetime. That's the equivalent of 100 billion trillion nuclear bombs detonating at once. Long-duration GRBs can release as much energy as the entire Milky Way galaxy produces in a year, all focused into a narrow beam. What makes GRBs so terrifying is not just their sheer power, but their reach. A long-duration GRB, typically caused by the collapse of a massive star into a black hole, can send a collimated jet of radiation across vast stretches of space. If Earth were ever caught within such a beam from a nearby source, the results would be catastrophic. The gamma radiation would strip away the ozone layer, flood the planet with lethal UV rays, and likely trigger a mass extinction event. Some researchers even speculate that a GRB may have contributed to past extinction events in Earth's history. GRBs are divided into two primary types: long-duration bursts linked to hypernovae, and short-duration bursts thought to result from neutron star collisions. Both scenarios are catastrophic, but it's the unpredictability and intensity of the beams they emit that elevate them to one of the most frightening cosmic threats. We can't see GRBs coming. They arrive without warning and are often observed only after the damage would already be done. There's no known way to shield a planet from their effects, and they can originate from galaxies billions of light-years away, making them one of the few threats capable of causing devastation from unimaginable distances. The event horizon. The event horizon is not a place in the traditional sense, but a boundary in space-time surrounding every black hole. It was first described mathematically by Carl Schwarzschild in 1916, following Albert Einstein's publication of general relativity. This invisible perimeter marks the point at which gravity becomes so intense that nothing, not even light, can escape. Once crossed, return is impossible. The event horizon is not a surface or a wall. It has no physical structure. It is a mathematical threshold, a point of no return. Anything that passes this boundary is irrevocably pulled inward toward the black hole's center, toward the singularity. From the outside, an object falling into a black hole appears to slow down, freeze, and fade as it approaches the event horizon due to time dilation. From the object's own perspective, It crosses the boundary quickly and is stretched, compressed, and ultimately destroyed by tidal gravitational forces, a process known as spaghettification. The terror of the event horizon lies in its finality. It is the edge of causality. No signals can pass from inside to out, no observations can be made beyond it. In essence, it marks the limits of physical law as we know it. Space and time lose meaning beyond the event horizon, and our mathematical tools no longer function. We never actually observed an event horizon until 2019, when the Event Horizon Telescope released the first direct image of the shadow of a black hole in galaxy M87, located 53 million light-years away. What we saw was not the event horizon itself, but its shadow, a circular region surrounded by glowing gas being pulled into darkness. What makes the event horizon one of the scariest places in the universe is its role as a cosmic point of erasure. It is where the known ends and the unknowable begins. A frontier not just of space, but of reality, where even information, the bedrock of physics, may be destroyed. The singularity. At the heart of every black hole lies the singularity, a single point where mass is compressed into infinite density. While the concept of black holes was derived from Einstein's theory of general relativity in the early 20th century, the singularity itself was more rigorously defined in the 1960s through the work of Roger Penrose and Stephen Hawking. Unlike the event horizon, which can be observed indirectly, the singularity remains completely hidden and inaccessible to observation. The singularity is where all known laws of physics break down. General relativity, which governs the behavior of gravity on large scales, predicts infinite curvature of spacetime at this point. At the same time, quantum mechanics, which governs the behavior of particles at the smallest scales, has no way to describe or handle this infinite density. There is no unifying theory that can explain what happens here. This is known as the problem of quantum gravity. Inside the event horizon, every path in space leads inevitably toward the singularity. No matter what direction you move, space-time itself funnels you toward the center. As an object approaches, it is subjected to intense gravitational gradients. These tidal forces become so extreme that they stretch and compress matter until it is destroyed. From a scientific standpoint, the singularity is not just a place, it is the breakpoint of reality. Concepts such as time, space, causality, and physical existence become meaningless. This isn't just a theoretical flaw in our models. It is a real, physical destination that may exist in the cores of countless black holes throughout the universe. What makes the singularity so terrifying is that it embodies the limits of human knowledge. It is the point where mathematics ceases to function, where observations cannot be made, and where even the fabric of space-time collapses into something we don't understand. For humanity, the singularity is not only a destructive gravitational abyss, it is the ultimate unknown. Sagittarius A star. Sagittarius A star is a supermassive black hole located at the very center of the Milky Way galaxy, approximately 26,000 light-years from Earth in the direction of the Sagittarius constellation. Its existence was first suspected in the 1970s, due to strong radio emissions detected in that region. In 1974, astronomers Bruce Ballack and Robert Brown officially identified Sagittarius A star as a compact radio source using the National Radio Astronomy Observatory. The black hole is estimated to have a mass of about 4 million times that of the Sun. Yet, it is confined to a region no larger than our solar system. Its gravitational influence is so powerful that it affects the orbits of nearby stars, particularly a group of fast-moving stars known as S-stars, which orbit the black hole at incredibly high speeds. This motion provided some of the clearest indirect evidence of its existence long before direct imaging was possible. In 2022, the Event Horizon Telescope released the first ever image of Sagittarius A star's shadow, confirming visually what decades of radio and infrared data had strongly indicated: that a supermassive black hole lies at the heart of our galaxy. What makes Sagittarius A star so uniquely frightening is its proximity. While many of the universe's most dangerous objects are billions of light-years away, Sagittarius A star resides at the core of our own galactic home. Its event horizon marks the boundary beyond which anything, including light, matter, and even information, is lost forever. Anything that crosses this boundary spirals toward the singularity at its center. Though Earth is currently far enough away to remain unaffected, Sagittarius A star serves as a constant reminder of the quiet but destructive forces operating within our own galaxy. It is capable of devouring stars, warping time, and altering the structure of surrounding space. Should it ever become more active, say, by absorbing a dense cloud of matter, it could release powerful bursts of radiation with galactic consequences. Sagittarius A star represents a cosmic predator hiding in plain sight. It is dormant, invisible in regular light, and largely silent, yet it exerts gravitational control over everything in our galaxy. Its presence is a chilling demonstration that even the heart of the galaxy is ruled by forces we can barely comprehend. The Big Rip. The Big Rip is one of the most haunting theoretical endings to the universe, an ultimate doomsday scenario driven not by fire, cold, or collapse, but by the relentless acceleration of cosmic expansion. First proposed in the early 2002, the theory stems from the observation that the universe isn't just expanding, it's expanding faster over time, propelled by a mysterious force known as dark energy. What makes the Big Rip so terrifying is the implication that this acceleration might not level off or slow down. It could continue increasing indefinitely. If dark energy's influence grows stronger over time, then its repulsive force could eventually overcome every form of gravitational, electromagnetic, and even nuclear binding. Structures we consider permanent galaxies, stars, planets, atoms, would be systematically torn apart. It starts slowly. Galaxies drift further from one another. Then, galaxy clusters disband. In the final moments, solar systems are pulled apart, planets ripped from their orbits, and stars torn into fragments. Closer to the end, even atoms are no longer safe. Molecular bonds break, protons and neutrons dissolve. The fabric of matter itself disintegrates. In the last instance, before the final rip, space-time stretches infinitely fast. The laws of physics break down not at a single point, but everywhere, all at once. The Big Rip isn't just an ending, it's an unraveling. A scenario where the universe doesn't collapse into a singularity or fade into heat death, but tears itself to shreds from within. And the most chilling part? We don't know yet if it's coming. The strength and behavior of dark energy remain one of the biggest unknowns in cosmology. If it continues to accelerate unchecked, the Big Rip could be billions of years away, or, in a far more unstable model, it could occur sooner than we expect. The Big Rip represents a uniquely unsettling fate. Not a bang, not a freeze, but a cosmic shredding, where everything we know is ultimately unmade by the very thing that keeps the universe growing. Quasars. Quasars, short for quasi-stellar radio sources, were first discovered in the early 1960s, when astronomers detected strange points of light that appeared star-like but emitted radio waves, and exhibited extreme redshifts, indicating they were incredibly far away. The first confirmed quasar, 3C273, was identified by Martin Schmidt in 1963. It became clear that these were not stars at all, but the extremely bright and energetic cores of distant galaxies powered by supermassive black holes. At the center of each quasar lies a black hole millions to billions of times the mass of the Sunday. As gas, dust, and even stars spiral into the black hole, they form an accretion disk that heats up through friction to millions of degrees, emitting radiation across the electromagnetic spectrum. Quasars are capable of outshining entire galaxies. Some release 1,000 times more energy than all the stars in the Milky Way combined. The terrifying aspect of quasars is their raw, destructive power. The radiation they produce, especially in X-ray and ultraviolet, can travel across billions of light years. Their relativistic jets, launched from the poles of the spinning black hole, can stretch for millions of light years, acting like cosmic blowtorches that strip gas from galaxies and sterilize any planetary systems caught in their path. Fortunately, most quasars are located in the early universe. Because they formed billions of years ago, their light is only now reaching Earth. Today, fewer quasars are active because their central black holes have consumed most of the available matter. But the fear remains. If a quasar were to form near our galaxy, its radiation would wipe out Earth's atmosphere, render the planet uninhabitable, and disrupt or destroy any trace of life. We are lucky that the few quasars visible from Earth are billions of light years away, because up close, they are among the most hostile environments the universe can produce. Magnetars. Magnetars are a rare and extremely dangerous type of neutron star. first theorized in the early 1990s and confirmed through the observation of unusual gamma-ray bursts known as soft gamma repeaters. These compact stellar remnants are formed when a massive star undergoes a supernova explosion, leaving behind a dense core that collapses into a neutron star. In the case of magnetars, this remnant develops an ultra-powerful magnetic field, making it one of the most extreme objects in the cosmos. A typical neutron star already compresses more mass than the Sun into a sphere only about 20 kilometers across, but a magnetar's magnetic field is what sets it apart. It can be up to a quadrillion times stronger than Earth's magnetic field. This kind of magnetic intensity is not just theoretical, it's so strong that if a magnetar were located as far as the Moon, it could wipe every credit card on Earth, disrupt all electronic devices, and even distort atomic structure. What makes magnetars terrifying isn't just their power, it's their instability. Their magnetic fields twist and fracture the star's crust, occasionally releasing massive bursts of X-rays and gamma rays in a fraction of a second. One such flare in 2004, from a magnetar called SGR 1806-20, released more energy in 0.2 seconds than the Sun emits in 250,000 years. If it had been only a few light-years closer, it could have devastated Earth's atmosphere. Magnetars are unpredictable, violent, and very poorly understood. They don't announce themselves with visible light or heat, but with sudden, invisible radiation blasts that could fry spacecraft and cripple global infrastructure if one ever formed too close. There are currently about 30 known magnetars, most of them thousands of light-years away. But given how difficult they are to detect, astronomers believe there could be many more lurking throughout the galaxy. If even one were to activate within dangerous range, it could become a cosmic weapon, an invisible bomb in the sky detonating without warning. The dark flow. The dark flow is one of the most mysterious and unsettling large-scale phenomena in cosmology. It was first detected in 2008 by astronomers using data from NASA's Wilkinson Microwave Anisotropy probe. The researchers observed that clusters of galaxies were all drifting in the same direction, toward a specific region of the sky, at velocities exceeding 600 kilometers per second without any identifiable cause. What makes the dark flow so alarming is that this motion cannot be explained by any known gravitational structure within the observable universe. Galaxy clusters as far as 2.5 billion light-years away are all being pulled in the same direction. Yet nothing in that region, no superclusters, voids, or anomalies appears massive enough to account for the effect. Some scientists believe this might point to the existence of a massive structure beyond the edge of the observable universe, something so enormous and influential that it tugs on galaxy clusters across billions of light-years. Others have speculated more radically that it could be evidence of a multiverse, a realm beyond our known universe, exerting a gravitational pull we cannot see. The unsettling part of the dark flow is its implication that the universe may be larger, stranger, and more dangerous than we ever imagined. If this effect is real and not an observational error, it suggests that unseen forces outside our cosmic horizon are interacting with our universe. We can't see them, measure them directly, or understand them using current models of physics. To this day, the dark flow remains a subject of debate. Some studies using newer data, like the Planck satellite, have failed to reproduce the original results, while others continue to find hints of consistent movement. But the possibility that something unknown, possibly outside of space-time as we know it, is pulling on the largest structures in the cosmos is enough to make it one of the scariest ideas in modern astrophysics. Rogue black holes. Rogue black holes are solitary black holes that drift through space untethered to any galaxy, invisible and silent. While black holes are typically found at the centers of galaxies or within stellar systems, rogue black holes are ejected from their host galaxies through powerful events such as galactic collisions, gravitational interactions, or the violent collapse of massive stars. Their theoretical existence has long been accepted, but it wasn't until 2022 that NASA confirmed the first potential detection of a rogue black hole about 5,000 light-years from Earth using gravitational microlensing. What makes rogue black holes terrifying is their complete stealth. They do not emit light, radiation, or any electromagnetic signals unless interacting with nearby matter. Without accretion disks or surrounding material, they are effectively invisible to conventional observation techniques. The only way to detect one is through the way it bends and magnifies the light of background stars, an effect that requires precise alignment and is extremely rare to observe. Once ejected from a galaxy, a rogue black hole can wander through interstellar or intergalactic space for billions of years. If one were to pass through a star system, it could disrupt planetary orbits, tear apart stars, or even swallow entire planets, all without warning. Earth would have no way of detecting its approach until gravitational effects began to distort space locally, and by then, it would be too late to escape. Estimates suggest that the Milky Way alone could harbor millions of these rogue black holes, silently roaming the galactic outskirts or even passing through the disk unnoticed. Because they are black holes without an anchor, they represent cosmic bullets, traveling blindly through space and capable of total destruction without a trace. What makes them among the scariest phenomena in the universe is their combination of power and unpredictability. A rogue black hole doesn't announce itself. It doesn't shine. It simply moves quietly, invisibly, and obliterates anything in its path. TON 618 is one of the most powerful and terrifying objects ever discovered in the known universe. It was first cataloged in the 1950s during a survey of blue stellar objects, but its true nature wasn't understood until the 1970s, when astronomers realized it wasn't a star at all. It was a quasar, powered by a supermassive black hole of unimaginable proportions. Located approximately 10.4 billion light-years away, TON 618 is so distant that we see it as it existed just a few billion years after the Big Bang. At its center lies a black hole with an estimated mass of around 66 billion solar masses, making it one of the largest and most massive black holes ever detected. For comparison, the supermassive black hole at the center of the Milky Way, Sagittarius A, is only about 4 million solar masses. TON 618 is over 16,000 times more massive. What makes TON 618 so unsettling is its scale and energy output. The quasar emits more light than entire galaxies, and the energy released by its accretion disk is enough to be seen across the visible universe. The amount of matter falling into the black hole is so enormous that it outshines all the stars and its host galaxy combined, sending jets of radiation and plasma tearing through space. This raises fundamental questions about how such an object could even form. Conventional models of black hole growth struggle to explain how TON 618's central black hole reached its size in such a relatively short time after the birth of the universe. It suggests that black holes can grow faster and larger than we thought possible, potentially altering how we understand galactic evolution. TON 618 isn't just dangerous in theory. It represents the upper limit of gravitational consumption, a cosmic monster that dwarfs even the most extreme phenomena. If such an object were closer to us, it would be capable of evaporating atmospheres, tearing stars apart, and warping space on intergalactic scales. Its presence reminds us that in the depths of space, there exist entities so massive and powerful that they stretch the limits of physics and our own cosmic insignificance. The edge of the observable universe. The edge of the observable universe isn't a physical boundary, but a cosmic horizon, a limit set by the age of the universe and the speed of light. Light takes time to travel, and since the universe is about 13.8 billion years old, we can only see as far as light has had time to reach us. But due to cosmic expansion, that distance isn't 13.8 billion light-years, it's actually about 46.5 billion light-years in every direction. This defines a sphere around Earth known as the observable universe. The concept was developed in the mid-20th century, following discoveries about cosmic expansion and the Big Bang. As space itself stretches, galaxies farther away recede from us, faster than the speed of light, not because they're moving through space quickly, but because the fabric of space between us is expanding. What makes the edge of the observable universe so terrifying is what lies beyond it, nothing we can ever know. Anything past that boundary is forever invisible, not because it doesn't exist, but because light from those regions will never reach us. These galaxies and structures are not only unreachable, they are unknowable, permanently separated from us by the expansion of space itself. Even more unsettling is that galaxies near the edge are moving away so fast that their light will eventually stretch beyond detection. As time goes on, these galaxies will disappear from view forever, leaving the universe darker, emptier, and more isolated. This means that the observable universe is shrinking in terms of what we'll be able to see in the distant future. The edge of the observable universe represents more than a distance, it is a barrier to knowledge. Beyond it could lie an infinite expanse of galaxies, unknown forms of matter, different physical laws, or even other universes. We will never know. Not because we lack the technology, but because light and therefore information cannot cross that boundary. It is the ultimate isolation, a cosmic wall that defines the limits of what we can observe, measure, or even imagine. And as the universe continues to expand, that wall will keep moving farther out, pulling the rest of existence away from us into eternal silence. False vacuum decay. False vacuum decay is not a place, but a cosmic threat embedded in the very structure of reality. It arises from quantum field theory, particularly our understanding of the Higgs field, which is responsible for giving particles their mass. According to some interpretations, the universe may not be in its most stable possible energy state, what physicists call the true vacuum. Instead, we may be trapped in a false vacuum, a temporary, metastable state that appears stable but isn't. This idea first gained traction following the discovery of the Higgs boson in 2012. When physicists plugged the Higgs boson's mass, around 125 GeV, and the top quark's mass into equations, the results suggested that the vacuum of our universe might be metastable, meaning it could spontaneously collapse under the right conditions. If that were to happen, a small bubble of true vacuum would form somewhere in the universe and begin expanding outward at the speed of light. This bubble would rewrite the laws of physics inside it, changing constants, particles, and the very fabric of space-time. Any matter it touched, including galaxies, stars, and planets, would be instantly annihilated. Earth would vanish before any warning could be detected. What makes false vacuum decay so terrifying is its total unpredictability and unstoppable nature. It would occur without any signal. There would be no flash, no gravitational wave, no forewarning of any kind. It wouldn't just destroy life, it would overwrite reality. Electromagnetism might cease to function, atoms might no longer bind, and the universe itself could become a cold, lifeless void governed by alien physics. The only reason we continue to exist may be because the process hasn't randomly started yet, or because quantum tunneling events like this are incredibly rare on human timescales. But mathematically, the possibility exists, and it is encoded into the very equations that describe our universe. False vacuum decay is not just the death of a planet or a star. It's the death of everything, everywhere, instantly, a universal reset, wiping out the cosmos as we know it. Drifting alone in space. One of the most personal terrors astronauts face is the risk of becoming untethered during a spacewalk. If the safety line connecting an astronaut to the spacecraft snaps, and their small thruster pack malfunctions, there is no way back. They would drift farther and farther away into the void. The oxygen supply inside the suit would eventually run out, leading to suffocation. Afterward, the body would freeze and remain in space forever as a tumbling relic. The fear here is not just death, but isolation. An endless, silent freefall with no rescue. For comparison, imagine being trapped alone in the middle of the Pacific Ocean, with no land, boat, or rescue in sight. The ocean feels endless, but space truly is. Space junk. Earth's orbit is cluttered with human-made debris. There are over 30,000 pieces larger than 10 centimeters, and millions of smaller fragments whizzing around the planet at tens of thousands of kilometers per hour. This includes old satellites, broken rocket parts, and shrapnel from past collisions. Even a paint chip moving at that speed can puncture metal. The International Space Station has had to dodge space debris dozens of times, performing 32 evasive maneuvers between 1999 and 2022. If left unchecked, the problem grows worse, making future space travel dangerous and threatening the satellites we rely on for communication and navigation. Occasionally, some of this junk even falls back to Earth, landing as charred fragments in people's backyards. To put it in human terms, it's like driving on a highway littered with broken glass and nails at top speed. Except the stakes are much higher, every shard can be lethal. Asteroid and comet impacts. 66 million years ago, a roughly 10-kilometer-wide asteroid slammed into Earth near the Yucatan Peninsula, causing the Chicxulub impact that wiped out about 75% of all species, including the dinosaurs. This shows the destructive potential of space rocks. While astronomers have identified many near-Earth asteroids, New city killers objects a few hundred meters across can still appear without warning. If one just a few kilometers wide hit today, the initial explosion would flatten entire regions, and the dust and debris in the atmosphere could block sunlight for years, collapsing ecosystems and food chains. NASA has tested possible deflection methods, like the DART mission that deliberately crashed a spacecraft into an asteroid to shift its orbit. But until every potential threat is tracked, the danger remains. To compare, it's like living in a neighborhood where some houses randomly throw bowling balls into the street, except in this case, the bowling ball could wipe out civilization. Solar flares and coronal mass ejections. The sun powers life on Earth, but it also produces violent outbursts. Solar flares and coronal mass ejections are bursts of high-energy radiation and magnetized plasma hurled into space. Most miss Earth, but sometimes they are aimed directly at us. In 1859, a massive event known as the Carrington event struck Earth's magnetic field and disrupted telegraph systems across Europe and North America. If a storm of that magnitude hit today, it could disable GPS satellites, shut down power grids, disrupt radio, and cripple the internet worldwide. Astronauts outside Earth's protection could be exposed to lethal doses of radiation. Over longer timescales, the sun itself poses an even greater danger. In about 5 billion years, it will expand into a red giant star, likely engulfing Earth completely. A human-scale comparison would be living next to a power plant that keeps us warm and alive, but every so often releases explosions that could fry electrical systems, and one day, that power plant will swell and consume the neighborhood entirely. Cosmic voids. Cosmic voids are vast regions of the universe that are almost completely empty, containing far fewer galaxies than expected. One of the largest known, the Boötes Void, spans about 330 million light-years across. Where astronomers would expect thousands of galaxies, only a few dozen exist. If you were placed in the center of such a void, the nearest galaxy could be tens of millions of light-years away. This means you would see nearly nothing in all directions, just overwhelming blackness. Unlike explosive dangers, voids are not harmful themselves, but the psychological weight of absolute solitude in such an endless dark expanse is terrifying. To imagine it on a human scale, picture standing in the middle of a desert so large that the nearest sign of civilization is farther away than the entire Earth. Multiply that sense of isolation by millions, and you get the feeling of being lost inside a cosmic void. Rogue planets. Rogue planets are worlds that have been ejected from their home star systems and now drift alone through interstellar space. Without a star, they are frozen and lightless, locked in an eternal night. Astronomers estimate there could be billions, possibly trillions, of these wandering planets in the Milky Way alone. They range from Earth-sized rocks to gas giants, larger than Jupiter. The surface of a rogue planet would be unimaginably cold, and without sunlight, there would be no day or night, just permanent darkness. Some might retain heat deep underground or beneath oceans of ice, but life there would never see a sunrise. Beyond their loneliness, rogue planets are a potential danger. If one passed through our solar system, its gravity could disrupt planetary orbits, or even collide with Earth. On a human scale, it's like a massive stray boulder rolling through a crowded street. Most miss. But the possibility of one crashing through remains a frightening reality. Dead galaxies and the dark era. A galaxy becomes dead when it runs out of the cold hydrogen gas needed to form new stars. Without fresh fuel, no new stars are born, and the galaxy is left with only aging red stars that slowly fade. These red and dead galaxies already exist, glowing faintly with the last light of dying suns. Over time, they will grow darker until they are nearly invisible. The same fate awaits every galaxy, including the Milky Way. In the far future, trillions of years from now, when the last stars have burned out, the entire universe will enter what physicists call the dark era. This would be a cosmos of black holes, frozen planets, and burnt-out stellar remnants, with no new light being produced. To grasp the scale, imagine a city where every single light bulb eventually burns out and no replacements exist only here. The city is the universe itself, and the darkness lasts forever. Nightmare planets. Not all planets resemble Earth's relatively gentle environment. Some worlds are so extreme, they are often described as death planets. In our own solar system, Jupiter is one example. It could fit about 1,300 Earths inside it, and it is surrounded by radiation belts thousands of times stronger than those around Earth. Its atmosphere hosts storms like the Great Red Spot, a hurricane larger than Earth itself that has raged for centuries. Any probe or human descending into Jupiter's atmosphere would face crushing pressures, scorching heat, lightning, and suffocation long before reaching the core. Beyond our solar system, astronomers have discovered even harsher exoplanets. On WASP 76b, daytime temperatures reach about 2,400 degrees Celsius, hot enough to vaporize iron, which then condenses into molten iron rain on the night side. On HD 189773b, winds reach 7,000 kilometers per hour, carrying shards of glass that fall as rain. A human-scale comparison would be stepping outside into a thunderstorm, except the raindrops are molten metal or glass, traveling at supersonic speeds. Aliens. The possibility of extraterrestrial life is one of the universe's greatest unknowns, and that uncertainty is what makes it frightening. Scientists widely agree that microbial life may exist elsewhere, perhaps beneath the ice of moons like Europa or in the subsurface oceans of distant planets. But the real fear lies in the chance of encountering advanced civilizations. A society millions of years ahead of us technologically could view humanity as insignificant, primitive, or even expendable. Some theories, like the Fermi paradox, ask why we have not yet seen evidence of such life. One unsettling answer is that civilizations might regularly be eliminated by something more powerful before they become visible. For a human comparison, it is like being in a vast forest. You know animals live there, but you hear nothing. The silence could mean the forest is empty, or it could mean predators are hiding, watching, and waiting. Neutron stars and magnetars. When massive stars collapse, they sometimes form neutron stars, objects so dense that a teaspoon of their material would weigh billions of tons. Their gravity is extreme. If you dropped a small object from a few meters above the surface, it would hit with the energy of a nuclear bomb. Approach too closely, and the gravitational pull would stretch your body into a long strand of particles, a process called spaghettification. Magnetars are even more extreme versions, neutron stars with magnetic fields trillions of times stronger than Earth's. These fields are powerful enough to distort atoms and could erase credit cards from tens of thousands of kilometers away. In 2004, a magnetar released a gamma-ray flare so intense that, even from 50,000 light-years away, it ionized Earth's upper atmosphere. If one occurred much closer, it could strip away the ozone layer and flood the planet with deadly radiation. To put it in human terms, standing near a magnetar would be like standing next to an enormous MRI machine, magnified beyond comprehension. Except the scan would tear apart your body at the atomic level. Gamma-ray bursts. Gamma-ray bursts are the most powerful explosions known in the universe. In just a few seconds, a single burst can release more energy than our sun will emit over its entire 10 billion-year lifetime. They are thought to occur when extremely massive stars collapse into black holes, or when neutron stars collide. The radiation is beamed in narrow jets that travel across galaxies at the speed of light. If Earth were ever in the path of a nearby burst, the intense radiation could strip away much of the ozone layer and trigger a mass extinction. Some scientists even believe a gamma-ray burst may have caused an extinction event on Earth about 450 million years ago. What makes them terrifying is that they are invisible to human eyes. So, we would have no warning. One moment, the sky would look normal, and the next, lethal radiation would sweep across the atmosphere. A human-scale analogy would be walking through a city, unaware that a sniper is hidden somewhere, silent, unseen, and capable of ending everything instantly. Colliding galaxies. Galaxies are not stationary islands in space. They move and often collide under the pull of gravity. Our own Milky Way is on course to merge with the Andromeda Galaxy in about 4 to 5 billion years. When this happens, the two galaxies will pass through one another, their shapes warping into long tidal tails. Direct star-on-star collisions are rare because the distances between stars are so large, but the gravitational upheaval will fling many stars into new orbits and possibly eject some into intergalactic space. Gas clouds crashing together will trigger bursts of new star formation, while the supermassive black holes at the centers of both galaxies will eventually spiral together and merge, releasing immense energy. For Earth, if it still exists by then, the danger lies in our solar system's orbit being destabilized. To imagine this on a human scale, think of two massive cities slowly colliding. The buildings themselves rarely hit directly, but the reshaping of streets and foundations would scatter everything caught in between. Supernovas. A supernova occurs when a massive star reaches the end of its life and explodes. For a short period, a single supernova can outshine an entire galaxy, releasing vast amounts of energy and radiation. Any planet orbiting too close would be instantly sterilized, its surface burned and atmosphere stripped away. Even at distances of 25 to 50 light-years, the radiation from a supernova could destroy Earth's ozone layer and trigger a mass extinction. Evidence suggests that about 2.5 million years ago, Earth was close enough to a supernova that isotopes from the explosion settled into our oceans, possibly altering the climate. While no nearby stars are expected to explode soon, the red supergiant Betelgeuse around 500 light-years away is a likely candidate for the future. On a human scale, a supernova is like having a campfire suddenly turn into a nuclear bomb. It looks like a beautiful light in the sky, but if you are close enough to see it clearly, it is already too late. The Great Attractor. The Great Attractor is a mysterious region of immense gravitational pull located in the direction of the Centaurus constellation. It has a mass estimated at 10 million billion suns. Yet we cannot see it directly because it lies hidden behind the thick band of our Milky Way's dust. What we do know is that it is drawing our entire local group of galaxies, including the Milky Way, toward it at hundreds of kilometers per second. Scientists now think it is the central mass of the Laniakea supercluster, a massive cluster of clusters containing many galaxies and huge amounts of dark matter. Although it poses no threat on human timescales, reaching it would take tens of billions of years. The unsettling part is its hidden nature. We only realized in the late 20th century that such an enormous force was influencing our galaxy's motion. On a human scale, it is like discovering that your entire city has been slowly drifting toward an unseen whirlpool without anyone noticing. Quasars and blazar jets. Quasars are the blazing cores of distant galaxies powered by supermassive black holes devouring matter. As material falls inward, it heats up to millions of degrees, creating an accretion disk that outshines the combined light of billions of stars. The most powerful quasars emit energy thousands of times greater than the entire Milky Way. Some also fire enormous jets of particles at nearly the speed of light that extend for millions of light years. When one of these jets happens to be aimed almost directly at us, astronomers call it a blazar. The radiation from such a jet could strip away a planet's atmosphere and flood its surface with lethal radiation. Thankfully, the quasars we know of are extremely far away. Still, the idea of a cosmic death beam capable of sterilizing worlds across intergalactic space is terrifying. For comparison, imagine a lighthouse so bright and hot that even if you stood on another continent, its beam could still burn you. Only in this case, the lighthouse is a black hole at the heart of a galaxy. Dark matter and dark energy. Only about 5% of the universe is made of normal matter, the kind that forms stars, planets, and people. The rest is invisible to us. Roughly 25% is dark matter, and about 70% is dark energy. Dark matter exerts gravity and holds galaxies together, yet it does not emit or absorb light, and we still do not know what it is made of. Billions of particles may be passing through our bodies every second without interaction. Dark energy is even more mysterious. It acts as a repulsive force that accelerates the expansion of the universe, causing galaxies to drift farther apart faster over time. If this continues indefinitely, distant galaxies will eventually vanish from view, and the universe will grow colder and emptier. In some theories, dark energy could even cause a big rip, where galaxies, stars, and eventually atoms themselves are torn apart. On a human scale, it is like living in a house where 95% of the structure is invisible. You can feel its presence, but you have no idea what it is made of or when it might collapse. Black holes. Black holes are regions of space where gravity is so strong that nothing, not even light, can escape. They form when massive stars collapse or exist as supermassive objects at the centers of galaxies. Crossing the event horizon, the point of no return, means being pulled inevitably inward. Near the surface, the difference in gravitational pull between your feet and head would stretch you into a thin strand of particles, a process called spaghettification. From the outside, time appears to slow for anything falling in, while from your perspective, you plunge rapidly toward the singularity, a point of infinite density where known physics breaks down. Black holes also emit powerful X-rays from their accretion disks and, in some cases, generate jets that can scorch space across thousands of light-years. To make this more relatable, imagine wandering through a forest at night where some pits are so deep and invisible that once you fall in, not only can you never escape, but even the rules of the world itself stop working at the bottom. White holes and wormholes. A white hole is the theoretical opposite of a black hole. Instead of pulling matter in, it can only expel matter and light outward. No object can enter its event horizon from the outside. Though they have never been observed, white holes appear as possible solutions in Einstein's equations, and some physicists speculate they could be connected to black holes. In that scenario, material falling into a black hole might emerge from a white hole somewhere else, forming a wormhole or Einstein-Rosen bridge. A wormhole would act as a tunnel through space-time. potentially linking distant parts of the universe or even entirely different universes. The danger lies in the unknown. If such structures exist, they may collapse instantly, crush anything trying to pass through, or open into environments with completely different physical laws that would destroy matter as we know it. On a human scale, it is like stepping through an unmarked door without knowing if it leads to another room, a sheer cliff, or a furnace, except here, the door could open across galaxies or dimensions. Vacuum decay. Vacuum decay is a theoretical doomsday scenario where the fabric of space itself could suddenly change. Physicists suspect our universe might be in a false vacuum, a state that looks stable but is not the absolute lowest energy state. If a transition to a true vacuum ever occurred, it would create a bubble of new physics that expands outward at nearly the speed of light. Inside that bubble, the fundamental constants of nature, the strengths of forces, particle masses, even the rules of chemistry could be completely different. That means atoms, molecules, planets, and life would instantly disintegrate. There would be no warning. One moment, everything is normal. The next moment, the laws of physics are rewritten, erasing all structure. On a human scale, it is like standing on what seems like solid ground, only to learn the floor could collapse at any time, dropping you not into a pit but into a world where the ground itself no longer exists. The sheer size of the universe. Perhaps the most overwhelming and frightening place is not a single object but the universe itself. The observable universe stretches about 93 billion light-years across and contains roughly 2 trillion galaxies, each with hundreds of billions of stars. To visualize this scale, astronomers once pointed the Hubble Space Telescope at a dark patch of sky, no larger than a pinhead held at arm's length, and within that tiny spot, they found about 10,000 galaxies. Now imagine the whole sky filled. If you liked this video, you will also like the scariest places in the universe. Watch this next.